Hey guys, welcome to a new Statistician YouTube channel, and today I'm going to go over the binomial distribution and really go over sort of where it's useful and how to do some estimation with it. So let's quickly go right to it. It's used for basically a binary discrete data. Fancy way of saying it's basically used for things like yes and no, recovery, not recovery, does the stock go up, does it go down, do you approve, do you disapprove? So it's really just things for whether you have one of two choices. And so when you have a variable, it can take basically any state of two states. So summary statistics really are the best way to go about evaluating the binomial distribution. Calculating summary statistics is the easiest way to go about fitting binary data. And so like always, there's always the math part of statistical distributions that we have to talk about. So let's get right to it. So as you guys probably may have seen, here is sort of the formula for the binomial distribution right here. X here means the number of successes. So our X variable is really just a positive whole number, 0 going, possibly to infinity technically, of successes. X can be literally 1 success, 2 success, 3 success, whatever. The parameters are N, which we usually think of as the number of trials. In most applied data cases, it's the sample size, and P, the probability of our success, the sort of the outcome we're looking for. What's the probability that we get sort of one of those two events that we're actually interested in? And here, this little combinatory function, or combination, is really just n factorial over x factorial times n minus x factorial. Believe me, I have to look this up every time. When I do this, just because the way the formula is, it's very specific. Another distribution that you may have heard and that's very closely related to the binomial distribution while we're on is the Bernoulli distribution. It's actually a related family of the binomial distribution, and we'll actually have a separate video going over that. And so, like always, we want to talk about the mean of any statistical distribution. Of course, its variability. Here they are. The mean is actually really simple. This is seen in pretty much all introductory stats textbooks and topics. It's basically the sample size, n, or number of trials, times the probability of success, which is sort of that mean value. And the variance is just that sample size times that probability of success times the probability of failure, which can be expressed really easily as just 1 minus the probability of success. Again, they both depend on the true probability of success and the number of observations directly. So the mean and variance depend only on really its parameters, which really depend a lot on the data, as we'll see. And the other important point here is that these two statistics for the binomial distribution can be used to approximate the normal distribution. And so why is the binomial distribution important? Well, if we didn't already sort of alluded to that, well, here is the full list of reasons why it's kind of important. So here's sort of the full list of reasons why it's important. If we didn't already allude to it, it's essentially a standard for binary data. Anytime you have sort of a classification problem where you have two possible outcomes, it's sort of the standard that's used, at least as a reference to any other type of analysis or modeling. It's, of course, approximated by the normal distribution, which is always an advantage. It makes working with it very easy. Software implementation is really been sort of developed around that. So many softwares have sort of implemented it in a lot of different ways, and it's really one of the easiest ones to actually be implemented in software. And it's great for more sophisticated methods. So for example, if you're trying to learn a little bit about Bayesian methods or actually other machine learning techniques, the binomial distribution is actually a key distribution because it's fairly a simple case that's being modeled. It's basically yes or no, does something happen? And so your outcome of interest is yeah, maybe no, and it makes it very easy to model. It's also, interestingly enough, it approximates the Poisson distribution, which is another distribution for count data, which we'll talk about in a whole other video. And of course, with it being easy to implement in software, it's also easy to do simulations using this distribution. It's also easy to use in simulations. partly because the distribution is fairly simple and using software to make simulations. And so let's go to my favorite part, example time. In this example, we're going to use the Pima Indian dataset. So we've linked that to our GitHub down below if you guys want to check out this dataset. So let's take a quick look. Some of the data right here in our example. So you can see we're going to model the outcome diabetes. It's either yes or no. And not surprisingly, here's some of the summary stats. We see about 35% have yes diabetes. So that's going to be the outcome we're interested in this Pima Indian dataset. And here's actually sort of the maximum likelihood sort of estimation for the binomial distribution. And we can actually kind of see how the binomial density is actually the highest, right at about 0.35, which is about 35%. So really, without even invoking the distribution, you can really get at the fact that the summary statistics will lead you to key conclusions about the distribution. Also, you can kind of see that it has this normal-like shape. It's a little bit peaked, but you can kind of see how this actually approximates a normal distribution in some way. The peakedness sort of really comes from the fact that our sample size is pretty big. We have about 770 cases. Thanks for watching, guys. That's all we have for you on the binomial distribution. We actually also have a linked article down below that has more details on the binomial distribution than this video can really offer. We also have a Patreon link below, so if you really like some of the content that we have here, please provide your support. If you also really like us, please remember to also subscribe and hit that like button. And of course, until next time, happy mining.